All right, so before we start solving systems of equations with three variables, I just want to give you an idea what this looks like as far as if we had to graph them. So first of all, we have a new point. Our new points are x, y, and then z. So since we have a system in three variables, we have three axes. We have a new axis here, and this is going to be my x-axis, my y-axis, and my z. All right, so those are my three axes, the x, the y, and the z. Now, with my x-axis, this is my positive x. This side is my negative x. Now, if I have an equation that I want to look at 2x plus 3y plus 4z is equal to 12, I can go ahead and graph that by using intercepts, the same way that I would go through, but it's a little bit different. I have 2x is equal to 12. If I solve that, I would get x is equal to 6. So that would be over here at 6 would be one of my points. To do and find the y-intercept, it would be 3y is equal to 12, or y is equal to 4. And then for my z-axis, it would be 4z is equal to 12, and z is equal to 3. And the plane between all of these points would be the way this is graphed. Now, it's a lot more difficult to show this in the systems of equations piece, but I just wanted to give you an idea of what that looked like as far as what a graph of an equation in three variables would be. All right, so the first equation I'm going to go ahead and solve has three equations in three variables. Now, do know that when you are working with these, your answer will always be in the form of a point of x, y, and z. Our solution here, we already have one answer. That's x, y, and z is equal to 5. So I'm going to go ahead and put that piece in here. Now, what we're going to be doing with this is we're going to work backwards to find x and y. And we're going to do that by taking that z is equal to 5, and we substitute it into the equations. So let's go through and give these equations a name. This would be equation 1, this would be equation 2, and this is going to be equation 3. So we're going to go ahead and take equation 2, which is 2y minus z is equal to 7. And wherever I have z, I replace it with 5. So now I have 2 times y minus 5 is equal to 7. I add 5 to both sides. 2y is equal to 12, and y is equal to 6. So now I have my second variable, and I now know that y is equal to 6. All right, now that I know what both z and y are, I can go back into equation 1 and substitute back in those two values. So equation 1 is x minus y plus 2z. Oops, let me go ahead and fix that. That equation really should have a z here. It's not letting me fix it, but just know that was supposed to be z. That was just a typo when I started. So this is equal to 6. So I replace my y with the fact that I know that y is equal to that 6 that I just found. And I also know that z is equal to that 5 that was given to me. And I go through and solve for x, and I get x minus 6 plus 10 is equal to 6. I solve that and I get x is equal to 2. Now, that's my final answer that I have here, so all I need to now do is go through and write that as a point. My solution for this would be 2, 6, 5, and that would be my final answer for this portion. All right, so now this is a more hefty elimination question. So the steps that we're going to use here are, first, we're going to use elimination. We're going to go ahead and use elimination, and we're going to choose one of the variables to eliminate. When we do this, we will have 2 new equations with 2 variables only. Now, the key in this step is to go through and make sure we eliminate the same variable both times. So for this, I'm going to choose to, in this case, my choice, and it doesn't matter. You can do this many different ways, but I'm going to go ahead and choose to eliminate x. Now, to go through and eliminate x, what I'm going to do here is I'm going to go ahead and do equation 1. Let's go ahead and name these. So this is going to be equation 1, this is equation 2, and equation 3. So I'm going to go ahead and take equation 1 and add that to -4 times equation 3. Now the reason I'm doing that, if I go through and take equation 1, which is 4x plus y minus 3z, and I multiply -4 times equation 3, what I end up getting when I do that, it's going to be -4 times x plus y plus z is equal to -3. And when I do that, I get -4x minus 4y minus 4z is equal to 12. And now, what we have here is negative opposite coefficients. So when I go through and add these 2 pieces together, my x's cancel out, and that's what we wanted here. And now I'm left with -3y minus 7z is equal to 23. All right, so now I need to do exactly the same thing, only for another set. The first time I used equation 1 and equation 3, the next step, what I want to do here is I want to go ahead and now take equation 2 and equation 3. I want to go ahead and still eliminate those, the x variable. So in order to make sure that I eliminate the x variable, I need that negative coefficient. So I'm going to go ahead and multiply equation 3 by -2. So equation 2 was 2x minus 3y plus 2z is equal to 9. And when I go through and take -2 and multiply it times equation 1, which was x plus y plus z was equal to negative 3, that gives me that negative coefficient that I will have. That gives me my negative 2x minus 2y minus 2z is equal to 6. Now, this one's kind of nice because it has an added bonus when I go through and add those two pieces together. When I add this together, the x's and the z's happen to cancel out, and I'm left with negative 5y is equal to 15, and y is equal to negative 3. Now, if that didn't work out that way, what you would do is you would solve the system, the 2x2 systems of equations until you got down to one variable. But now that we have one solution, what we're going to do is just go ahead and go back into one of the originals. It does not matter which one I've done, but because I only have y, I want to go back into the equation that we solved the first time, which was negative 3y minus 7z is equal to 23. And since y is equal to negative 3, I just go through and replace that y with a negative 3. So it's negative 3 times negative 3 minus 7z is equal to 23. You get negative 7z is equal to 14. And the fact that z is equal to negative 2. Now, you just take those x's and, the y and the z that we just solved, and you can plug it into any of the three. I'm going to go ahead and choose equation 3 for that. And equation 3 was x plus y plus z was equal to negative 3. And we already have two of those solutions. So to find x, I say x plus negative 3 plus z, which was negative 2, is equal to 3. And I find out that x is equal to 2. So just remember to make sure you write your answer as a point, and that point would be 2, negative 3, and negative 2. It's always in the form x comma y comma z. I'm not going to do any more of the 3x3 systems of equations, only because when we are going to use matrices for these the majority of time in class, but I did want to give you a few examples before we went on to matrices.